All right, folks, time for some unit vectors. There's two of them that we deal with in this class. There's more than that in a lot of other classes, but at least two, at least for us, at least for now. And they are unit vectors, introducing them to you now, x hat and y hat. Okay, so x with a little point on the top means you say that x hat and you say that y hat. Okay, this is a vector of unit size in the x direction. Y hat is a vector of unit size in the y direction. By unit size, I mean their magnitude is 1. That's what I mean by unit size. Magnitude of these units, that's why they're called unit vectors. Okay, magnitude is 1, and they're dimensionless. There's no meters or meters per second or newtons or anything associated with them. They're just these little vectors. X hat points in the x direction, has magnitude 1 and no dimensions. Now that seems like a pretty weird thing, doesn't it? Why would we care about x hat and y hat? We can invent these, but why? Well, I'll tell you, it's because things get sort of easy. It's easy to express other vectors in terms of them. They're very, very useful. Remember last time, last lecture, last video, last two videos, we talked about a vector A that was 3.75 meters in the positive x direction, or north. Positive y direction, what we call north, but let's just call it positive y. We talked about a vector B that was 2.25 meters in the positive x direction. And we talked about two other vectors. Vector C was 2.12 meters in the positive x direction and 2.12 meters in the negative y direction. Remember, that one pointed this way, southeast. It changed in both x and y, so it had components in both directions, x and y. The x was positive because it pointed to the right. The y was negative because it also pointed down. It pointed down and to the right. And we finally had vector D, which was, let me get the numbers here right, it was 4.37 in the positive x direction and 1.63, say, in the positive y direction. So D pointed up and to the right. So it was positive in x and y. Remember, that was the pink resultant vector from the last video, last two videos. This all day today, we've been talking about A plus B plus C equals D. And these are our vectors right here. Well, the thing about unit vectors is it makes these vectors really easy to write down. This is certainly true what I've written, 3.75 meters in the positive y, 2.25 in the positive x. C was more complicated. It went 2.12 meters to the right, 2.12 meters down, which is negative y, and then D was up and to the right, so it was positive x 4.37 and positive y 1.63. So that's certainly a way to communicate them, but it's awkward and it's not streamlined. You know, how do you say this? How do you put the direction and the magnitude together neatly to describe a vector? Okay, this is one way of doing it. There's lots of other ways we can do it. The neatest, most direct way of doing it is using unit vectors. And here's what it looks like. We could write these vectors this way. It's a little bit awkward. It's a little bit cumbersome. But we could also write A as 3.75 y hat meters. Let me see, actually, let's do it this way. Yeah, 3.75. It doesn't really matter if you put the meters at the end after the y. I think that the meters should probably come first. 3.75 meters, yeah, that's how you should do it in the y hat direction. So that tells you that A is directly up in the y direction. All the y hat does is tell you the direction of that vector, which is up. So B is 2.25 meters in the x hat direction. Not in the, you don't say x hat direction, you just say x direction. X hat tells you it's the x direction. But the real good stuff comes in when you have more complicated vectors like C and D that have components in both x and y. C now can be written 2.12 meters in the x direction plus, I'm sorry, minus, because it's minus y direction, minus 2.12 meters in the y hat direction. I did it again. I said y hat direction. I need to stop saying that. You don't say that. You just say y direction. So I would write C is 2.21 meters in the y direction, in the x direction, and 2.12 meters in the negative y direction. Not the y hat direction. It's not a thing. And finally, D is 4.37 meters in the x direction plus 1.63 meters in the y direction. So using these unit vectors makes writing out vectors very straightforward. And notice too that if I just add up all the y hats, 3.75 minus 2.12, I'll get, if I add up all the y hats of A, B, and C, I'll get the y hat of D. 3.75 minus 2.12 is 1.63. If I add up all the x hats, I'll get the resultant x hat. 2.25 plus 2.12 is 4.37. So it's just a shorthand way of writing vectors, okay? And it tells you direction. That's what unit vectors do. It is, and the usefulness right now might not seem that great, but I assure you over the months to come, you will see how unit vectors are very, very handy indeed. It basically is a way of making, indicating direction in a very simple, very efficient, convenient way. That's what they do. Okay, that's what unit vectors do. And finally, we could discuss when we were in downtown Decatur, right? The total displacement vector from the old courthouse to Victory would be 200 meters x minus 300 meters y. That is a perfectly good way to describe that displacement vector. We could also describe the same vector by saying r hat was 361 degrees. What was the angle there? It was at minus 56.3. Sorry, that's to be 361 meters. At minus 56.3 degrees. Either one of these, in this case, R is written in terms of its components, right? Because 200 meters is Rx, negative 300 meters, I'll do it that way. Getting a little tired here. Negative 300 meters is Ry. You can do it in terms of components or in terms of its magnitude and direction. These are two equivalent ways of writing the same vector. These two are, if I asked you to give me the vector R, displacement vector from the old courthouse to Victory, either one of these would be perfectly fine. Okay. So in general, one more statement about unit vectors is that I've got any vector A. No, let's not pick A. Let's pick a vector P, right? I'm P, so my name's Paul. So P can always be written as the x component of P in the x hat plus the y component of P y hat. That's like the first statement here. These two are both in terms of components. Now Px could be anything, Py could be anything, but in general, this is how you express a vector in terms of components, where Px and Py are the components. I could also write P equals the magnitude of P at some angle theta. They are both equivalent. These two that I've circled are the component way of writing it. And the two I've circled in blue here are the magnitude and direction way of writing it. So these two are magnitude and direction. And the two others circled in pink are components. Two different ways of expressing a vector. These two R vectors are exactly the same. And these two P vectors are the same. Okay. So that's it for unit vectors. About subtraction, only one thing to say about subtraction. If I've got a vector here, let's see, let me pick a vector. Okay. Suppose I got this vector here. Suppose I got a vector A equals 2 in the x direction minus 3 in the y direction. That looks like this. Actually, let me make the axis blue. Do this right. So here's our axis, x, y. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Okay. So that vector, 2x minus 3y, says that we go 2 steps in the x direction, 3 steps in the y direction. That's the end point of our vector. Our vector is right here. It goes 2 over and 3 down. Okay. Point sort of to the southeast, in the roughly southeast direction. So that's our vector. That's our vector A right there. Okay. And we can also write this vector. This is the same. This is in terms of components. We can also write it as 3.6 meters at, what's this angle? Negative 56. Those are the same vector. Here I've written it by components. There I've written it by magnitude and direction, when our theta is right here. So minus A, I'm going to do this in a different color. So minus A is minus 2x plus 3y. That vector looks like this. So now we're going in 2 steps in the minus direction in x, 3 steps positive in the y direction right there. This vector looks like this. This is minus a. I just changed the signs on both the components. But I can also write this as 3.6 meters, and it's the same magnitude, but the exact opposite direction. Now we have, see, this angle here, that theta, green theta, and that will be at 124 degrees. Right, 0 this way, 90 there, and then plus some more to 124. So the clip and save here is that the magnitudes in both cases are the same. A and minus A have the same magnitude. But opposite direction. That's the clip and save. So when you subtract a vector, you simply mean it's the same as adding a vector that's pointed in the opposite direction. Okay. All right, so we're way over on this video. Let's clamp it down and fix it, and I'll see you all next week. Hope you're doing well. Take care, y'all.